then decimals and working with, then binary search. Last week we covered binary search. Then we covered binary search, which is advanced implementation when working with decimals. Then we covered topics which were interactive problems, how to work with interactive problems, interactive plus binary search. And then last we looked at some ternary search problems. So in last class, theory is completed, right? And we did some problems, but like since we were running out of time, I couldn't discuss each and every problem that I wanted to discuss. Like there were around 3-4 problems that I wanted to discuss but couldn't discuss. I tried to give those problems as a part of doubt resolution or daily problems, but I don't think I don't want to give each and every of those problems as daily problems, because first of all, like there are some problems that require like that help you learn something, and there are some problems that are just implementation and on which you can like practice. So the problems that I had earlier selected were problems that help you learn something. Like from those problems you can get like those are not that implementation heavy, they just help you learn these topics. So first of all, coming to this is clear to everyone, right? Binary search, simple binary search. Yes, no, anything? So today, see what we're going to do. We are going to do some very nice problems of these topics. So for see, till now I have planned to give this thing majority of the time. Like we'll try to give around 50% or 60% of our time to this. Then we'll give around let's say 25 to 20% of time to this, and again around I'll say 15 to 20% of time. Why I have decided this? See, this has already been covered. See, binary search is everywhere. If you don't have an intuition of binary search, you won't be able to ace in these topics. So in a way, this will be getting covered in these only. But see, binary search advanced, I think we did around 3 or 4 problems last week. So this should be clear. This also we did around 2 or 3 problems, but like problems of this you'll find if you right now if you just search ternary search topic in problem set in code forces, you'll find only 20 to 25 problems, and around 50% of the problems will be more than, I would say, 2400 rated. So right now, since like we are not targeting you, should like I'm not making you ready to solve these problems, but you should be ready to solve these problems. If you search interactive, you'll find at least, I would say, 200 plus problems. This 200 is a very low number. You will find more than these problems on interactive, on code forces, and out of which around 70% will lie between, I would say, 1600 to 2100. So if you're able to solve these problems, see, in division 3, every other division 3 contest and majority of division 4s have one of the interactive problems. If you come to educational rounds, very frequently these problems are asked. So that's why we are going to give 50% to 60% of our time of today's class to these problems. And then also we are going to give a little time to these. So first of all, is this clear to everyone? Okay, so let's start. So first, let's try to solve. Okay, let me open the problem once. So my screen is visible, right? Okay, so now, okay, someone, okay, I won't be looking at the chat while I'm explaining, so don't expect that I will be answering your like each and every doubt if you write it in the chat. I'll answer once after I have finished explanation part. So let's try to first solve this problem. So I dropped this problems link in the chat also. Okay, I have shared it to one there. This is the link. Now let's go through this problem. So in this problem, Vlad has n friends from for each of whom he wants to buy one gift for the new year, and there are m shops in the city, in each of which he can buy a gift for any of his friends. Now, if the jth friend, j is between 1 to n, receives a gift bought from the shop with the number I is between 1 to m, then the friend receives, this jth friend receives pij units of happiness or units of joy. Now, Vlad has time to visit no more than n minus 1 shops, where n is the number of his friends. Now he chooses which shop he will visit and for which friend he will buy gifts in each of them. So let the jth friend receive AJ units of joy from Vlad's gift. We have to find the value alpha such that this is minimum of this, like the friend which is getting the minimum joy, and Vlad's goal is to buy gifts in such a way that alpha is large as possible. That means the friend who is having the least joy, we have to minimize that least joy value for the friend. So in other words, Vlad wants to maximize minimum of the joy of his friends. So this is one of the examples. So first of all, is the problem statement clear? Then I'll cover one of the examples. Is it clear? Yes, no. See, today's session is just going to be discussion. So there's no point. See, if you want the session to be fruitful, you have to participate in the session, right? You have to participate in the discussion. So see, let's take an example. So first we are given m and n as input. So in the, let's take the second example. So m is 4, n is 3. So this means there are 3 friends and 4 shops. So now we are given this 1 3 1, 3 1 1. Then we are given 1 2 2, and then we are given 1 1 3. So this means if the first, in the first shop I buy the gift for the first friend, he'll get 1 as the joy. So this way we are given this, all these Pij values, and finally we have to print like each, the answer for the maximum value alpha, where alpha is the minimum of the joys from a gift for all of Vlad's friend. And now what
Hello.
are the, yes yes yes,
Can I buy a gift for two friends from the same shop?
you have to do it, because see, if you're not, see, that is what I was coming to. If there are only n shops, like you can only visit n minus 1 shops, so you are at least buying, for 2 friends you're buying a gift from only 1 shop at least. Like it's possible that you buy for all your friends, you buy the gift from only 1 shop. It's possible that you're buying it from 2 shops. Suppose you have 5 friends, you're buying all these 5 gifts from 1 shop. You can buy them from 2 shops, but you cannot buy, like you can at max go up till 4. You cannot buy these 5 gifts from 5 different shops. This is not possible. Like you can only buy from n minus 1 shops at max. So is the problem statement clear? So in this problem we are only
So
allowed
I
to visit
so
2 shops.
hello.
Yes yes,
So I have to leave one shop. That
you
is
have to leave.
one shop.
You, like, actually you don't have to leave 1 shop. You can, because see, m can be more than n. So you are not actually leaving 1 shop, you are just going to n minus 1 shop. So actually you are leaving m minus n minus 1 shops. So if m is equals to n, then you are leaving 1 shop. Otherwise you are leaving this number of shops, right?
Okay.
So first of all, is the problem statement clear to everyone, like what is asked to us? Yes, no, anything?
I got disconnected. Can you again explain how you got disconnected?
Okay, so we are given, and we have n friends. Assume that there are n friends and there are m shops. M is more than or equals to n. Okay, if m is more than or equals to n, then we have to find that if it's possible for us to buy, like what is the minimum. See, these Pij, this means that these are the number of shops, these are the number of friends, these are the friends. So if for the ith, for the first friend I buy the gift from the first shop, then he'll get a 1 unit of joy. Otherwise, if for the second friend I buy the gift from the first shop, he'll get 3 units of joy. This is first friend, second friend, third friend, right? This is first shop, second shop, third shop, fourth shop. So this way we have to maximize the the joy of the friend which is getting the least joy. And the constraint is we can only go up till n minus, like we can visit at max n minus 1 shops. We cannot visit n shops. Is it clear now?
Yes.
So now tell me, like, all your thoughts. If what are you thinking? How to solve this problem?
So we can do binary search on maximum and sort the every array and use lower bound to find the count of number which are greater than my current mid. And also take the count of how many shops I visited. And if at last it is less than n minus 1 and my count number is greater than n, so I can use that method or else reject that.
Okay. So okay, actually I was not able to understand. Like you are saying that we'll binary search on X whether or not we are able to get this as the least value, right? Able to
Yes.
get this as the least value of our joy for any of the friends. Now how to actually check whether this is possible or not?
So we will sort every array and we will use lower bound for each shop, like how many values are greater than equal to x, and we will also like count
If
how
you
many.
sort it, if you first of all, if you sort your p values, then how will you know whether you have already chosen, like whether you have selected a gift for some kth friend or not? But because initially p is like this, if you sort this array, how will you know whether this 3 is for friend 2 or whether it is for friend 3? How will you know this thing
Okay,
if you've sorted?
I got it.
Okay. So now, okay, this thing is correct, that we try to find whether x, we are able to get x as the lowest value of our least joyful friend or not. But how to go from here? See, first let's look at the problem statement once again. So let's look at the constraints. See, you have to first carefully look at the constraints, and in this problem we are given that n into m is 10 to the power 5. So we can implement something that is like for each binary search iteration we can have n into m operations, right? Yes, no? Like we can completely go through this grid. N into M is nothing, but we can completely go through this grid. So now, if this is true that we can go through the complete grid, so how do you think, what should we do? See, first we went to shop one, and now what should we do? See, if we find that this friend is, if I buy a gift from this shop for any friend, first of all, the joy that he should get should be more than X, right? Yes, no, anything? See, if I'm buying, this is shop one and this is my friend three. So if I decide that from shop one I'll buy a gift for friend three, this value should be more than X, more than or equals to X. Yes, no, anything? Like, just unmute yourself and let me know.
Yes.
Okay. So from this shop, I can buy for each of the friends, let's say 3 and 5, if these values are more than equals to X, right? So finally, see, I completely iterate through my grid. I'll maintain two variables, two arrays. One is shop count, and the another one is, let's say, whether or not, let's call it okay, whether or not I have already bought. Okay of J will tell me whether or not I have bought a gift, I was able to buy a gift for friend J. And shop count will tell me, shop count of I will give me how many times, how many gifts I'm buying from ith shop, how many gifts I'm buying from ith shop, how many gifts I'm buying from ith shop, ith shop. So these are the two things. Now, if I'm able to buy these two gifts from the first shop, what I'll do, I'll increase shop count of 1 by 2 times plus equals to 2, and my okay of 3. Okay of 3 will be 1, and okay of 5 will also be 1. What does these two things mean? That I was able to buy gifts for these two friends, and I was able to buy two gifts from shop 1, right? Yes, no? Okay. So finally, after I have completely traversed my grid, what do I need to check? Can someone tell me? What do I need to check? Whether or not, how to, like, I have to check only these two things, these two arrays. How to, what to write here such that it's possible for me to have X as the, like, a value which is more than or equals to X as the lowest joy of any friend.
Like
What to
okay
write?
will be true for everyone, and shop count of every index, like for one index it must be greater than one.
Okay, yes, perfect. Perfect. So, okay for every friend should be true. Why this is? Because I was just checking that if the value is more than X, then I'm able to buy a gift for this friend. So if okay for a friend is never equals to 1, okay for a friend is never equals to true, this means that I was not able to buy a gift for this friend. And I have to eventually have to buy a gift for each and every friend, right? So first of all, is this thing clear? Why okay for every friend should be true?
Yes.
Okay, and the second thing is that the shop count for at least one shop should be more than 1. Now, why is this true? If I'm able to buy at least from one shop, I'm able to buy gifts for two friends, then that's enough. That is more than what I need. Like, that is sufficient, right? Because if I'm able to buy at least two gifts from a shop, then eventually I can buy all the gifts from n minus one shops, right?
Yes.
Because at the end I have to buy only n gifts from one shop. I'm able to buy at least two or more gifts. So that's why eventually I'll be able to buy all the gifts from n minus one shop. So if both of these conditions are true, I'll return true. That means that I can get X, at least X as my lowest joy for a friend. So is this clear? Is anyone having any doubt in this? Shop count can be 3, shop count can be n also. You can buy for each of the friends, but I'm just checking that shop count is shop count more than n, like more than 1. Do you get my point? Is anyone having any doubt in this? See, first of all, from this problem, you need to learn that how you actually, if you're applying binary search, you just have to look at the problem. Forget about binary search part. You just have to look, if you're given X, how will you verify? So usually binary search is followed by some greedy. So what is greedy in this? We are trying to look whether or not we are able to buy from any shop, we are able to buy two gifts, and whether or not we are able to buy for, like, each friend we are able to buy one gift or not. So this is a really good problem. If you look at usually 18 plus 100 problems are of this pattern only. Problems which are less than, I would say, 1600 or 1700 don't follow usually this pattern. Like, you don't actually have, you are given maybe an array, or you just have a simple check condition. But in problems which are more than 1700, the check, like the binary code, is really simple. The things that you do in your check function is the core logic of the problem. So is this clear to everyone?
Yes.
Okay, so can I show you the implementation really quickly? So let me get the implementation once. Where is it? Just give me a minute. So this is visible, right? The code, is it visible? Yes, no?
Yes.
Okay, so let's go through this quickly because I've already explained the logic, and I would prefer that you guys solve this on your own, but let's quickly just go through this just for the sake of completeness. So in this, I'm first taking n and m and n as input. Then these are the p values, that is m cross n grid, that is given to me in input. I don't think I'm using this mm max everywhere anywhere. So yeah, this is actually not being used, I think. So then this is the shop count array of size m, and this is my OK of size n, array of size n. So this is for friends, this is for shops. So let's first come to this part. So like I said in previous class also, we have to identify the lower range, like the lower boundary and the higher boundary for a range. Then while low is less than high, actually we can have an equals to here, we'll have an equals to here. So while low is less than high, what will we do? We'll find a mid value, then we'll check if it is possible at mid. My low is mid, otherwise my high is mid minus 1. And instead of writing this, like this is a better implementation. Low is equals to mid plus 1. So otherwise you won't have to check something here. Like otherwise sometimes you'll have to check, maybe not for this problem, but sometimes it's possible that your final low, if you're printing low, then your low is not your correct answer, but it is low minus 1. So this always works. Answer. So answer. So first of all, is anyone having any doubt in this part? Then we'll look at the check function, possible function. Yes, no, anything?
Yeah.
Okay, so now let's come to this part. So this is the core logic of this problem. So first, I'm making everything in my shop count array 0, and I'm making everything in my OK array also 0. So this represents whether the ith friend has received a gift or not, and this represents how many times I'm able to buy a gift from the ith shop. So I'm iterating through my grid for the jth friend, and from the ith shop, I can buy a gift if p of ij is more than x. So I'll increase my shop count of I by 1, and I'll make OK of j as 1. This represents that I'm able to buy the gift for the jth friend, and I'm able to buy one more gift from ith shop. So finally, I will check if the maximum value of this array is more than 1 and the minimum value of this is more than 0. So actually, I just can check is equals to 1. That the minimum value is 1 itself. So this means I was able to buy gift for each and every friend, and at least from one shop, I'm able to buy more than one gifts. So I can return true. Is it clear?
Yes. Yes.
Okay, is anyone having any doubt right now? Just write.
In the
Yes.
max element one, why we are always checking greater than one? Like I understand if there is a difference of one, the greater of one would hold.
Okay.
But
see, why we are checking that maximum of shop array is more than 1, right? This is your doubt, right? Yes.
yes.
Okay,
Yes.
so if I'm not checking this, if my shop count is equals to 1, let's say maximum value is not more than 1 but equals to 1. So this means that, and my OK is OK for each and every friend is 1. So this means I was able to buy a gift for each and every friend, right? This means that I was able to buy for each friend a gift, right?
Yes.
For each friend. And this means that maximum gift that I bought from a shop is 1. So how many shops would I have visited if I bought n gifts and
And
this is n? So this cannot be, like, this is not what I want, right? I only want to visit n minus 1 shops, not n. In the
yes.
problem statement, if I only want to visit n minus 1 shops, not n, my maximum of shop count should be more than 1. Like it should be more than or equals to 2. There should at least be one shop from which I'm buying 2 or more gifts. Is it clear?
And
Okay. But please don't, like, okay, I think if 2 or more people are speaking, I won't be able to understand. So like carry on one by one. So first of all, whose doubt was this? Is it clear to that person?
like I understand in this. Okay, I understand.
Like there is, if shop count is equals to 1, it simply means that you have visited n shops and you cannot visit n shops. So that's why maximum value of your shop count should be more than or equals to 2. And anyway, this will already make sure that for each friend you have bought a gift which is having, like, from which he or she is getting a joy of more than x. But you also have to make sure that you don't visit more than n minus 1 shops. So that's why we are checking shop count should be more than or equals to 2. Is it clear? Okay, first of all, let me know, like, is every student facing this? Like, for this, like, I'm not able to hear students properly. Their voice is breaking. So this is for only for me, or is everyone feeling this?
Even I can't hear this voice properly.
Okay. So I would ask that kindly write your problem like your doubt in the chat. And my voice is my voice audible to everyone? It's clear, right?
Yes.
So most probably, if you are facing some issues, like if you're not able to hear me clearly, just check if like your internet is stable. So the problem is, what if m is 3 and n is 4? So if m is 3 and n is 4, I don't think the answer will ever exist. So in that case, see, if you cannot visit n minus 1 shops, if n is 4, okay, if n is 4 and m is 3, that case also will work. And first of all, like I said, I think in this problem statement, if you read, like, let me go through the constraints once. So one gift and j friends and m friends, and this is there, this is there. So we are given this thing, n minus 1 shops. In the shops you can buy a gift, and then we are given that there is a line containing m and n is more than equals to 2, and m and so in that case also you'll get the answer, right? If m is 3 and n is 4, then also this logic will work, because then also you'll get a shop with for which you're able to buy these many, like at least you're buying 2.
Hello, sir.
Yes.
But what if from one shop I can
Yes.
buy 4 gifts, and next I will not able in next shop maybe there is
Then also,
possibility that
yeah, it's
will
also
not get.
possible that you're buying all the gifts from one shop only. So instead of 4, you can buy all the gifts from one shop only. Is it okay?
But can we buy single gift multiple times?
Like, okay, like you won't buy one gift 2 times from a shop, right? You won't buy for a friend, you won't buy 2 gifts from one shop. Like, you won't buy a gift again and again. It is like, in at most we have to visit n minus 1 shops. We cannot visit n shops at most. Is it clear?
Yes.
Like, your yes doesn't sound like convincing. See, like, why will you, like, first of all, the problem statement, I don't think you have understood the problem statement. If, like, let's say these are the values, why will you buy this gift 2 times? Like, you only buy each gift once, right? And it's possible that if, like, you had something, you're buying 3, like you have to buy gifts for 3 friends, and you bought all the 3 gifts from the first shop only. So this is possible, but you will not buy this gift 2 times, and finally you would say, like, for each friend you have to buy a gift only once, right? So if you buy this gift twice, it means that from the first shop you bought the gift for friend 2 twice. Are you getting my point?
Yes. I understood that the overall count, suppose it's if it's it at least n, we're able to buy n gifts, then we'll distribute. We should be able to buy n plus 1 gifts.
No,
Is
no,
it?
no. You will buy n gifts only, but you'll
N
buy
gifts,
them
sir.
from n minus 1 shops. You'll try to buy
Okay.
them from n minus 1 shop. You'll try to buy them from 1 shop, 2 shop, 3 shop, like this. All these things work for you. So you just check whether you're able to buy them from n minus 1 shop. So if you're able to buy them from n minus 1 shops, at least from one shop you're buying more than or equals to 2 gifts. At least from one shop, one of the shops, you're buying more than 2 gifts. Is it okay?
Yes.
So this is clear to everyone, right?
Yes. Yes.
So what if we had something like, also we had some budget, then this problem is completely different. Then this problem would convert into a dynamic programming problem, and the constraints will be lower down. So I won't be discussing that because that is not the topic for today's class. So let's go to the next problem. We have to discuss many problems, and already I think we are lagging. So now let's discuss like an interactive problem. So first of all, was this problem discussed in last class? Guess the KH0. No, right? I think it was discussed. Yes, no, anything?
Yes, it was discussed. This was discussed. F2 was not discussed.
Yeah, this was discussed. I also remember this. So this is a standard problem of interactive problems. So instead of looking at this, let's go directly to this one, C2. So this is another problem, guessing the greatest. So was this problem? I don't think this problem was discussed. I didn't cover 1900 rated problems last time, I think. Right? This problem was not discussed. So this problem, actually, this is just a base of interactive problems. Like, so if I have already discussed it, I won't be going over this again. So I hope everyone has an idea how interactive problems work. So I'll directly come to this problem. I'll first share the link in the chat. Okay. Now in this problem, we are given that there is an array A of n different numbers. In one query, we can ask the position of the second maximum element in a segment A of L to R. And we have to find the position of the maximum element in the array in no more than 20 queries. So second maximum element is nothing but, see, if there are 1 to 5, let's say in our current array, there are elements, it is a permutation of 1 to 5, then 5 is the maximum element, second maximum is 4. So there is an array A of n different numbers. Make sure that like you understand this thing. This is very important, that there are n different numbers. All the numbers are unique. And then in one query, we can get, for any range, for any L to R, we'll get the second maximum element, and we have to find the maximum element. So, okay, this thing is clear to everyone, right? We ask queries this way, and we print answer this way. So maximum query should be 10, n is up till 2 into 10 to the power 5. So this is a very nice problem, like the previous problem that we discussed, that was guessing the kth 0. So kth 0 was very standard, you have to find the kth 0. So working with prefix sums worked there. But now the problem statement has changed a little. Now the problem is that we have an array of n unique numbers, and we have to find the maximum element, like the position of maximum element. We have to find the position of this. But in a query, if you ask a query from L to R, we get the position of second maximum. So how do you think we should solve? Any idea? Like, it's important to discuss your idea also, because how will you know that like your idea, maybe whether it was right, whether it was wrong? So that's why, if you have something in mind, you can discuss it right now. Anyone? Okay, I won't discuss this immediately, like give it a thought first. You know everything, like you know binary search, you have solved interactive problems. So how will you solve this?
So I think first L to R must be the whole array.
Okay.
It will give us a position of second maximum. So now the array will get divided in two parts. The first one will be L for 0 to the position -1, and position plus 1 to n -1. So we'll check the position of second maximum, this one, both the arrays. If the position of second maximum is different, means if the element is greater, then we'll
Yes,
check.
I get your thought process, and this is how you solve these problems. See, once I solve this problem, you feel like this problem is not even 1300. You'll completely feel like this. This is how interactive problems are. You just have to have your thought process, and after a point, once you are like around, once something clicks in your mind, then the implementation plus the like the way you use, like you don't have to use any algorithm, you don't have to do anything, you just have to have a simple implementation. So see, first of all, let's say this is my complete array. Okay, this is my complete array. So can I ask, using one query, what is the second maximum of this, right? What is the second, let's call this as S max. S max is the index of the second maximum element in this. So now let's say this came out to be this. Now let's say this is my mid. So can I ask, what is the second maximum of this part? If these two second maximum indices are same, what does this mean? Can anyone tell me what does this mean?
The maximum lies in the other half.
Why in the other half? Why does maximum lie in the other half if the second maximum of this range is same as the second maximum of this range?
Maximum lies in this
We
half.
lie the same.
Yes, maximum lies in this part. Why? See, every element is unique. If every element is unique, let's say this was 10 and my 12 was here. So initially, this 12 is my maximum and this 10 was second maximum. Now still also it is second maximum. So there is one more element which is more than 10 in this part. And since I already know this 10 is second maximum, so that element is maximum, right? Yes, no, anything?
Yes.
Yes.
But if it changed, if now my S max, earlier it was 10, now my S max is 9. So what does this mean? Like this is the index of second maximum. So this means now the thing that was earlier acting as second maximum has now become maximum, because the complete maximum of this array is not present in this range. So that means it is present in this range. Is it clear? Yes, no?
Yes.
Is it clear to everyone? Otherwise, I'll explain this again. Like, this is how interactive problems work. Okay, I'll again repeat this again. But other than that, first tell me every doubt that you have. Then I'll cover all those at once. If you are facing any doubts. Okay, so let me again walk you through the process. See, we have an array, and let's say in one query from L to R, I can get the second maximum position S max. Okay, and I have to find in at max 20 queries what is the maximum. So, and one more thing is given to me that the elements of array are all unique. So if you find the maximum of like second maximum of this range, let's say that this was somewhere here. This is my second maximum index. So can I not say, let's say that this is my mid, this is my mid index, this is my low, this is my high. So let's call this as R. So if again, like for this range, if in this range, if my S max, if S max second, this is my S max second for this second range. If this is equals to earlier X max, like these two are same. So what does this mean? That my maximum is lying in this range only, right? In this part. Otherwise, it's lying in this part. Is it clear? Is it clear to everyone?
Yes.
Okay. So after this, there is nothing. See, we'll keep dividing a range into two. See, if I changed my L to see if my maximum is lying in this range, let's say, see what I'm doing every time I'm finding my mid and I'm checking, okay, in which range, in which left part or right part is my maximum lying, and I'll change my left to, like if I'll change my left. So each time my range is getting divided by 2. So finally, and I'm making sure that my maximum is somewhere between L to R, right? My maximum is somewhere between L to R. So finally, when L is equals to R, this means that I have found my maximum, right? Yes, no, anything? If I'm always making sure that maximum is somewhere in between my L to R range, when L becomes equals to R, then there is only one index in my L to R range. So that's why that is the answer itself. And now let's also calculate the number of queries. How many queries are we actually using? Queries are nothing but log 2 10 to the power 5. Is anyone having any doubt in this? I explained this in the last class also, how I calculated this. If anyone is having any doubt, let me know. So this is nothing but, if this is x, 2 to the power x, which is 10 to the power 5. So x will be somewhere close to, I think, 17 or 18. So these are the number of queries in which your answer, like these are the number of queries that you'll ask in order to get your answer. Is it clear? So 17 only. So the complete logic is clear. The time complexity, like the number of queries that we are asking, is also clear. And okay, this is also clear. So can I show you the implementation?
Yes.
Okay, so let's look at the implementation once. Just give me a second. Okay. I don't know why indentation has, like the indentation is not correct, but I'm not correcting it because it doesn't matter. So first of all, like this is the ask template that, like I provided this to you, I think in the last class also. So this is nothing but from L to R, you will return what is the second maximum. So in the problem statement, it's given that the range that you're asking your answer in, like the range that you're asking, for the range that you're asking the second maximum for should be more than, like it should have at least 2 elements. So in case your L is equals to R, return 0. So this is just for, like this won't actually happen. Why? Because I'm simply doing if L is not equals to R. This means L is not equals to R. But anyway, like this can be possible if there are exactly 2 elements in mid C. It's just when, if I have 2 elements and my L is this, R is this, L is not equals to R, and my mid becomes this thing, and I ask what is the maximum, second maximum in this range. So that's why it will return 0. So anyways, because this doesn't mean anything. Otherwise, I'll print L and R. I'll take X as input. I've already told you why to use end L here and not use \n. I've explained this in detail in the last class. Then I'll take N as input. Then my second maximum, initially second maximum between L to R, 1 to N is this thing. Now till when my L to R is not same, I'll find the mid. I'll find if my second maximum in this range is equals to this maximum, this means that my maximum is somewhere in left part, right? Like I explained, this and this, if this is same, then my max is in some left part. So that's why I'm changing my right boundary. Otherwise, I'll change my left boundary. Similarly here, if S max was in other half. So first you have to check where S max is, right? If S max itself is in right half and you're checking that what is the second maximum of the right range itself. So if it is equal to this thing, then I'll shift to the right range. Otherwise, I'll shift to the left range. Is it clear? Is anyone having any doubt in this?
No.
This is clear, right? So this is, I think this is 1890. This is a 1900 rated problem. So you see, this is not that hard. You can easily solve this problem, and this problem will appear as something maybe D problem, C or D problem in division 2. We are using mid plus 1. Why we are using mid plus 1 here? Why we are using mid plus 1? See, because eventually I am taking mid into consideration here. So that's why if mid is coming in both of these, then my left range and right range will have an intersection, like they will have a common point. So if mid is already in left part, don't take it in right part. Is it okay?
Why from 1 to mid? Why not from L to mid? Like was the first question was if if ask 1 to, so we can also do L to mid, no?
Yes, we can also do like that way. Your operation will like the number of operations will decrease faster. You can do mid, L to mid and mid to R. But eventually, like I said, if you divide the complete 10 to the power 5 range into by 2 by 2 by 2 each time, eventually you'll get number of operations as 20 only. Is it clear? Like you can, this is a better way to do it if you're doing L and R. But like I said, see, can anyone tell me why this also works? Can anyone tell me why can I write 1 here instead of L? Why?
It's something in
Your voice is not clear, like you are not audible. Can you repeat yourself? Someone said something. See, eventually I have to find the maximum element, right? I have to find the maximum element of this range. And if my current L to R is from here to here, that means I've already discarded this thing. This is not my maximum anyways. So if I finally do from here to here and here to here, what does it mean? Like eventually my answer is in this range only, right? L to R. And I have already discarded this range. So I won't get my final maximum in this part. There is no way that my final maximum will lie in this. Is it clear? Okay. So this problem is clear to everyone, right? Is anyone having any doubt in this? Yes, no, anything? Is anyone having any doubt?
भैया
Yes, yes.
इसमें हम एस मैक्स की वैल्यू अपडेट नहीं करेंगे हर वाइल लूप में, या फिर वो फर्स्ट वाली रहेगी?
Actually, if you're updating, like I said, if you're calculating, like I have submitted this code and this also works. So there will be an explanation for that also. If you're not updating S max value, see, S max is initially here and you checked that your range. So this is also okay. You don't actually have to update S max. Why? Because let's say this was here and you are actually like S max is not in your L to R simply means that this range is having your maximum. And S max simply acts as a way of checking that whether or not your L to R is still having the maximum value or not. It is a kind of a pivot. This is the second
Okay.
max value in the complete array, right? And
Yes, yes.
L2R, what is L2R? L2R is the range in which your maximum is lying, not your second maximum. So when I'm decreasing my L2R and I'm doing everything, in those cases, my maximum, I'm making sure that maximum is still in this range. Is it making sense? Like once try to submit by changing S max also. If you write it correctly, I think it should also work. But you'll have to work around, like you'll have to write the code, you'll have to change it slightly, but it should also work.
Okay, भैया.
Like binary search plus interactive problems are really easy. If your fundamentals are clear, you can easily code these problems out. So see, you don't actually have, that's why I usually don't like prefer showing solutions and completely walking through you my solutions, because once I have shown you my solution, you'll be like eventually like you'll have the intuition of following that only. But if I only would have told you this thing, that how to solve this problem, then I think you would have eventually been able to solve the problem on your own also, right? But anyways, so we'll shift to the next problem. But this is clear to everyone, right? The logic is this thing, like try to solve this problem on your own. Is the logic clear to everyone? Like everybody knows how to approach this problem, right?
Yes. Yes.
Okay. And like otherwise, like if you see my code, maybe I'm doing some unnecessary computations or I'm doing something which is unrequired and it becomes more complicated, and then you try to find reasoning why I'm doing this. So the best practice is once you learn something, instead of following the exact code of the mentor, try to solve this problem on your own. So we'll go to the next problem. Okay, there's one more doubt. The doubt is we are checking 17. See, I checked that my number of queries is 17 because you'll also have to check after before writing the code. Actually, for interactive problems, it's always better to check if you follow the approach how many queries you are asking, because if you are asking it around 22 queries, you'll get wrong answer or maybe runtime error. So it's always better once you write the complete implementation, try to get the maximum number of queries that you'll be asking in worst case. So that's why I checked that what are the number of queries. So I found that my number of queries, if I follow this method, is 17. So if 17 is less than 20, then my solution will work. Is it clear? Okay, how do like you number of queries, you have to count it. See, these are the number of queries, right? This query plus one. So how many times these query will be asked? Each time my range is getting divided by 2. So like I said, I explained this thing in the previous class also. If your range is getting divided by 2, simply take log of it, and this is your number of queries. So x come out to be 17. So since I asked one more query at the beginning, my x will be, like the total number of queries will be 18. So I think we can shift to next one. So first of all, let me know, am I going too fast, too slow, or is it okay? So let's look at this now. So this is another interactive problem, and this is also one of a kind problem. So that's why, like, we'll discuss this also. So in this problem, we are given that initially there is an array A of array A having these values 1 to n, and like each value from 1 to n appeared once in the array A, and all the values were unique. So now we are given that n is an odd positive integer. So n is odd, the length of this array is odd, and the jury has selected n minus 1 by 2 disjoint pairs of elements, and then the element in those pairs are swapped. For example, see, if 1, 2, 3, 4, 5 is there, 1 and 4 got selected and they are swapped, 3 and 5 are selected and they are swapped, so we'll get 1, instead of 1 we'll get 4, instead of 4 we are getting 1. So instead of 5 we are getting 3, and instead of 3 we are getting 5. So as a result of these swaps, exactly one element will not change the position. So we have to find the position, or like that element whose position is not changed. So to do this, we can ask several queries. In one query, we can pick two integers L and R, and in return, we will give the elements of the subarray in the sorted order, in increasing order. Like if we ask a query from L to R, we get this all the array elements from L to R in sorted order. We don't get the actual order, but the sorted order. So we can at max make 15 queries, and we have to answer, like we have to find the element which didn't get swapped, n is up till 10 to the power 4. So first of all, is the problem statement clear? Yes, no, anything?
Yes.
Okay, so we are given an array. Initially, everything was like 1, 2, 3, 4, 5, 6, 7. Let's say n is 7. Then we selected n minus 1 by 2. So in this case, we'll select 3 pairs. So let's say these two got selected, these got selected, and these two got selected. So now we'll swap these. So our array will become 4, 7, 3, 1, 6, 5, 2, right? So there is exactly one element that didn't get changed, like the element whose position didn't get changed. So we have to find this element. And in a query, we can, let's say we pass L to R. So if we pass L to R, what we will get? We'll get the elements in the new array, we'll get them in sorted order 1, 2, 5, and 6. So can someone tell me how to solve this problem now? Any idea?
भैया एक बार लिंक बताना प्रॉब्लम.
Yeah, I'll get the link also. Okay, first of all, is this clear? Like this is an interactive problem. You have to ask queries, and you have to finally find, this is an interactive problem, right? Why is someone having any doubt that whether or not this is an interactive problem? You're asking queries, in return you'll get something. So these are different variations. Like previously, what you used to get, if you ask a query, you used to get, for the query you used to get one value. Now instead of, like, if you ask a query, you're getting all the elements, like you're getting a vector, and this vector is nothing but all the values in new array in sorted order. So is anyone having any idea, like any random thing that is coming to your mind? Try to observe something. See, binary plus interactive are only observing. Try to observe something crucial. See, any idea? Anyone? Any idea? Otherwise, I'll start. Okay, either write yes or no. Otherwise, how will I know that you are trying or you are not trying? Should I wait or should I? Okay, someone has said something. What about others? Okay, some are trying. Okay, I'm waiting. Okay. So think about this, because once I tell you the solution, you'll see that okay, this would have easily come. Like you would have been easily been able to solve the problem.
I have an approach.
Yes, yes, yes.
So basically, what we'll do is that we'll maintain a range low and high, 0 to n minus 1. First we'll
Okay.
maintain. Then we'll
Okay.
find the mid of it,
Okay.
and then we'll query for low to mid.
Okay.
And initially the array is 1, 2, 3, 4 up
Yes.
to
Something
n.
like that.
Okay,
Yes.
but so we get a subarray, and
Yes.
if we find that the position are actually means that we don't get the matching position, then the element which is fixed may lie in the other half.
Like
That is
how will
mid
you
plus
check?
1.
How will you check that the element that is like fixed is lying in this half or in other half?
So in the original arrays itself, 1, 2, 3, 4
Yes.
up to mid. It should be up to mid.
Yes.
So if all of them are unsorted, all of them are mixed up, it may lie in mid plus 1 to high.
If they are like, I still didn't get you.
So the original must be 1, 2, 3, 4
Yes.
up to
And
mid.
yes. And if you
But
ask a query and you are getting something like, let's say you are getting
something array which
you are again getting 1, 2, 3, 4. So what does this mean if you get 1, 2, 3, 4? That whether your fixed
we
element
have to find the fixed position, no?
yes.
Then it may lie in the first range itself.
No, because this doesn't. If you get this, it's possible that the array after swapping was this thing 3, 4. So then also you'll get this thing, but this doesn't mean that the fixed element is in this range, right?
Okay.
So let me tell you. See, this is an easy problem. See, we have to just observe and okay. So if we are asking a query from L to R, let's say we iterate, we get elements like x1, x2, all the way till let's say xm. So there are m elements between this range. So we just have to check whether x1 is like, originally we would have something like 1, 2, 3, 4, 5, 6, 7. So we just have to check the new elements that we received. The new elements that we received, that is x1, x2, x3, x4, and x5. We just have to check for each of these elements whether or not how many elements are actually lying between L to R. How many elements are lying between L to R? If the number of elements that are lying in between L and R is odd, then we can surely say that the fixed element is in this range only. Is in L to R. How? See, if let's say this is our L, this is our R. So if two elements got swapped, so get swapped inside only, like in this range, two elements got swapped among themselves. So both of these places will have what? Both of these places not in their original places, right? Yes, no, anything? So
Yes.
Yes.
if both of these elements are not in, so the count, like, but still these are in here only, like these elements are still in here. So our value of number of elements that are inside this range, that should have been inside this range, that are also inside this range, increased by 2, right? What should I like what I said, we have to count the number of elements that we get in like in response. We have to see how many elements are actually lying between L to R, right? How many values are between L to R? So if two elements that were initially between L to R got swapped among themselves, then the number of such values that I finally get as x1 and x2, that value will get increased by 2, right? Because initially also these two elements were inside LR, and now also these two elements are inside the range LR, right? Yes, no, anything?
What is this value
not
plus
get it.
equal to 2?
Okay, value is nothing. Okay, what? Okay. I'll just mute. So see, we have L to R. We found mid. and let's say currently, okay, let's not take LR as this. Let's take L and R as our this range. So I'm saying if initially there were two elements that got swapped between L and R only. So both of these elements, see, this was 3, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, and 9, and 10. So this, and we'll have 11 elements, right? Because n is odd. So now if my if L2R, if between L2R the array elements like 3 and 7 got swapped, then what does this mean? That initially finally I'll get, if I check from L2R, I'll get in my sorted order, I'll get 3 and 7 also, right? There will be some other elements also, but there will be 3 and 7, right? Yes, no, anything? So
Yes.
finally, when I'm counting how many values in my input, how many values that I get in my response are between L and R. So L is 2, R is 8. How many values are between these? So if a swapping like this happens, my value will increase by, always my value will get increased by 2, because for 3 also and 7 also, if this kind of swapping takes place, right? Is it making sense? What about others? And initially my L to R is odd. See, my range was
But
odd, right? Okay, yes.
3 and 7 are already into this range now. So how are values getting increased? 3 and 7
See,
are already in this range.
yes, 3 and 7 are already, I'm counting how many values lie between this range. So that's why 3 and 7 lie in this range only, right? So that's why it is getting increased by 2 if a swap like this happened.
Okay.
Okay, and now I'm also given one thing, that my range currently, if I always keep my range odd, what does this mean? That, see, initially my range n is odd only, right? And I'll always keep L2R odd, and finally LR, like my range will end up when my range is 1. So I'll always keep my range odd, and I already know if something swapped like this, like if my current LR is this and some elements got swapped among themselves, then the value, that is the number of elements that are inside this range, that were already inside this range, it will get increased by 2. It will get increased by 2. But otherwise, if there is a single element, okay, actually I don't have to, let's not complicate this. This is not required. Forget about this, that the range is odd. I'll make it simple. You just have to check. See, first of all, tell me one thing. What is my value? Okay, I'll write this completely again. I think many people are getting confused. See, okay, why is it not clearing? See, first of all, let me write the value. What is value? Forget about LR, forget about range. It doesn't, like, we don't have to worry about that. See, all I'm saying, my value is, see, in my response, if I ask a query L to R, I'll get some elements from XL plus 1 all the way till XR. Is this thing clear? Now I'll just check, out of all of these elements, my value is nothing but, value is number of elements out of these which lie, number of elements which lie between L and R. Is this thing clear? Between L and R, between, and like they can be equals to L and R also. Is this thing clear?
Yes.
So how will I check this? If X, see, initially at Lth position I had L, at Rth position I had R. So how will I check how many elements are this? I will simply do
R minus L plus 1.
Yeah, you can do value plus equals to whether X of I is between L and R or not. If this is true, value will get increased by 1. Now I'm saying, if you're initially, let's say this is your L and R. So I'm saying if some elements that is were inside this range only and they got swapped, then the value will always get increased by a factor of 2, because these two were already inside, they got swapped among themselves. Now also they both are inside. So for both of these, you'll get 2. So eventually, like finally, your value will get increased by 2 if this kind of swap is happening, right? Yes, no, anything?
Yes.
Value is clear why it is getting added twice. So, but if my value comes out to be odd, what does this mean? Value comes out to be odd. Like there are odd number of elements that were initially in this range. That is odd. What does this mean? That there is at least one element here that didn't get shifted, yeah. Otherwise, how is it possible that my value can come out odd? Is it making sense? Can I? What did you say? Okay, your voice is breaking. Okay, someone is saying if they are swapped from other parts. See, if this element got swapped from some element which is outside this, then the value that you'll get because of this element in your response won't add 1 to your value. What I'm doing, value plus equals to whether X is between L and R. it is less than or equals to r. So if in case this value got swapped somewhere like outside this range, then this value will now not be giving you 1 because of this. And for all the other values that are getting swapped inside only, you'll get 2. So how will you get value as odd? That is what I'm saying. That meant that there is one element that was initially also inside, and right now it's also inside, and it didn't get swapped at all. Did you get my point now?
Yes.
Okay, who all are having doubt in this? Like right now you can ask me, otherwise like we'll move ahead. Okay, I'm not adding 2, I'm just saying that it will get added twice. I'll do this thing only. I'll do this thing only, and then I'll check value is whether value is odd or even. I'll do this thing and I'll check whether value is odd or even. I'm not adding 2. I'm just saying if in my current range, if from L to R there were 2 elements that would have got swapped among themselves, then eventually my value will get added by a factor of 2. So how can I get value as odd? If I'm starting from 0 and I'm adding 2 because of all of these, so how can my value end up at odd? So my value can only end up at odd when there was at least one element here which didn't get swapped at all. Because see, okay, let me write all the 3 scenarios. My L is this, my R is this. There are 3 scenarios. This element got swapped with this element got swapped with itself, this element got again swapped with this element, and this element didn't got swapped with any other element, right? So if this element got swapped with this element, now this element came here because of this. Is this element between L and R? Is it between L and R? Okay, so this is not between L and R. Is this element between L and R finally? That element that I'll get here. Okay, is this element between L and R that I will get finally?
Yes.
Okay, is this element between L and R that I'll get finally?
No.
Is this element between L and R that I'll get finally?
Yes.
Okay, so how many elements are between L and R?
3.
So this means that the element is between that didn't get shifted is between L and R. And this is what I mean by value plus 2. If some elements are getting swapped between among themselves in range L and R, then value will be getting incremented twice. Value will be getting incremented twice. This is what I mean. Once for this element, once for this element. Is it clear now? So if anyone is still having any doubt, unmute yourself and ask me right now. Otherwise, I'll show you the code. Range shouldn't have I ever mentioned that L to R is you can complicate, it will be a little more complicated, but this works, right? I'm not saying LR is even or LR is odd. This works for every scenario. If the number of values that you're getting in between, that should have been in between only, if they are odd, then this simply means that the element that didn't get shifted is right now in this range only. Okay, so let me show you the implementation. Okay, where is it? Okay, here.
Hello.
Yes, yes,
I have one question.
yes.
Like if we can ask for a range, it will provide us a sorted array. Then why can't we ask for full array and then compare each value?
You don't have the original array itself, right? So if you ask for the complete range, it will give you 1 to n. What will you do with this? It will give you 1, 2, 3 till n. What will you do with this?
Okay. I thought we have array.
If you had the original array itself, something like this, then you could have simply answered, right? Like this thing is not in its place, because finally the array initially would have been something like this only. So there is no point in asking for this. Okay, like you should have asked this at the start, not at the ending, when I've discussed the complete solution. So anyway,
Okay.
I'll show you this is the implementation. So first I'm taking n as input, then initially low is 0 and high is n minus 1. Like I said, these are the boundaries, and somewhere in between I'm having a place at which the value is, like the number which didn't get swapped is there. So while low is less than high, what I'm doing, if my mid is this, if count of this turns out to be odd between low and mid, then my answer is somewhere between low and mid, right? So instead of doing it like this, I'll do somewhere between low and mid. Okay, if this turns out to be odd, this means that my answer is somewhere between low to mid, right? No, not between low to mid. It is, yes, it is between low to mid, right? Yes, no, anything. And otherwise, I'll shift to the other part. So what is happening here? I'm counting in my count. Okay, I've unnecessarily complicated this thing. You shouldn't do it like this. Generally, in ask, you should simply return what you get in input. You shouldn't make computations there, because otherwise, once you start debugging, the this problem is a simple problem, but once you start debugging different problems, you should always make this count function something like it's taking an input and it's giving you output, and it's not having any it isn't having some computations calculated inside. So what we are doing, since L and R were initially zero indexed, I'm printing L plus 1 and R plus 1. I'm counting how many places are there such that X is more than L plus 1, and X is less than R plus 1. So X is lying between L to R. Now, I'll return this count, and similarly, if I'm just checking whether or not this is odd or not. Is it clear? Finally, I can print this. I won't suggest it like this. It's always better to take answer. But I think I implemented this problem 2 or 3 years back. So at that point, I used to implement problems like this. So is it clear to everyone?
Yes.
Is anyone having any doubt? Let me know right now. Otherwise, I'll shift to another problem. You should have an idea about these problems, how these problems work, because eventually you'll find that these are really simple problems, and you could have easily solved these problems during the contest, but because you didn't knew that these concepts existed. See, to be honest, these problems, the logic behind these problems is around 1300 rated, 1300 or 1200 rated, but the problem itself is 1800 rated. So that's why it's always better if you know these topics, you'll always get an edge during the contest. So let's go to the next problem. We have around half an hour. I think they should. I think it's okay. We'll be able to discuss this problem also. Now coming to we have discussed enough of those interactive problems. I hope that all of you are now comfortable with it, and you know how to solve those problems. But let's discuss on advanced. See, some advanced BS problems. I think last time some people were having doubt in these topics. If we had to, when we had some error and we were working with high, while high minus low is more than error, the problems like this. So we had some error. So let's look at a problem which covers these kinds of things. So here is the problem. I'll share the link in the chat also. And actually, this is also a ternary search problem. You can solve this using ternary search also. So if you look at this is not an interactive problem. This is a binary search and ternary search. So actually, it's not binary. It's kind of you'll be working with decimals. So let's go through this problem. In this problem, we are given that the main road in the byte city is a straight line from south to north, and conveniently there are coordinates measured in meters from the southmost building in north direction. Now at some point on the road there are n friends. The ith of them is standing at the point xi meters and can move with any speed not greater than vi meters per second. Now in any of the two directions along the road, from south to north or from north to south. Now you are to compute the minimum time needed to gather all the n friends at some point. Know that the point at that they meet doesn't have to be an integer coordinate. So you have finally you have to find the minimum time needed for n friends to meet. So try this problem once. You know everything that is required to solve this problem. So once try this problem, and once you give up or once you find the solution, let me know. Then I'll discuss this problem. How do you think we should solve this problem? You are trying, right? Yes, no, anything? I've already shared the link in the chat. Okay, please let me know when you're done.
Hello.
Yes.
We can do binary search or answer and then check connected to the array of each friend and check their speed whether they can go to that point or not. You can do this.
How will you check this? How will you check this? That is.
We have the coordinate and the speed of
Yes.
each person, so we can check using that.
But at what point are you meeting? How will you know this person can go either in north direction or south direction? So in which direction you are moving this person? How will you know that?
That depends upon the coordinate that I have picked. Like if I want in north direction, then I will move.
Okay, let's say you are currently let's say this is your line, you're currently here, your friends are here. So where are you trying to move these friends? Are you trying to move this down, this up, and this up? Like how are you moving these?
Can we do it with the ranges? Means in that amount of time, it can
Yes.
go from L to R,
Yes,
and we'll just point if they're all of them are colliding at
Yes,
one point.
Yes, that's actually right. Because see, first of all, you don't actually have to find the place of collision. So you shouldn't worry about the place where they are meeting. You don't have to find the point where they are meeting, right? You just have to minimize the time. So see, there are two ways to solve this problem. First is binary search. The second one is ternary search. See, first of all, why ternary search? Ternary search works with distances. See, if let's say this is my minus 10 to the power 9 and this is my 10 to the power 9, each of your friend is somewhere in between, right? Each of your friend is somewhere in between, right? Yes, no, anything?
Yes.
The position are always positive, right?
Assume it to be negative if it's already like, actually yes, I can write this as 0 also, but assume that these is the complete coordinate line and some of your friends are lying, like some of your friend is here, some here, some here. And now how will you know if everybody wants to meet at this point? Can you find the time? Yes, no? Can you find the time? How will you find the time? What is the time of it? Is nothing but the time taken by the maximum, like maximum time taken by any friend, right? Take maximum time taken by any friend. So this is the value. Then tell me one thing. If this is the scenario, whether the time to reach this point will be less or high, whether it will be low or high. If this is the scenario, all the friends are here.
Low.
Yes. Why? Because see, the time, the friend which was taking time, like that every friend has to travel 1 unit less now. So finally, this will be the times. Like this is how I'll get something. This is a inverse. This is a parabola, a U-shaped function, right? These are the times. So time to reach, if my meeting point is this, if my meeting point is this, if my meeting point is this, these are the times, right? Let me draw this again. So let's say these are the time units. So eventually I'll get something like this. So this is nothing but these are the time, maximum time taken by any friend, f friend to reach x, and these are x values. Is it clear? Is this thing clear? How I'm getting this function, U-shaped function? Yes, no, anything? Okay, what about others? Is it clear?
Yes.
So on this, you can apply ternary search. Take your low as this, take your high as this, and your mid 1, mid 2, and try to find this point of minima. I have already explained this in detail. So there's no point showing the code twice for the same problem, but is this clear to everyone? Can everyone solve? Like, you have the confidence that you can solve this problem, right? In the last class, I discussed one ternary search problem, and I think it was like difficult for level 3. So, but is this problem clear? Like,
Yes.
okay, now I'll also we'll also solve this problem using binary search. So how to solve this using binary search? In ternary search, we took distances as our x, like we were operating on distances. In binary search, what we will do, we'll try to take time. We'll try to binary search on time. Here we are ternary search, we're operating on distances. Now we are operating on time. So how? See, our time can be from 0 to let's say 1e9. So let's pick the mid time, and for each, see, this is your range, let's say, and your one of the friends is here, one of the friends is here, one of the friends is here. So let's say you pick the mid as your time, and you know that this guy will be able to travel from here to here in this time. Like, actually it will be symmetrical because he has, its speed, its initial position. So this guy will be traveling from here to here, right? This guy will be eventually able to travel from here to here, and this guy will be able to travel from here to here, right? Yes, no, anything? You can calculate these values, right, for each of the times. So let's pick L as the maximum of these L's, and let's pick R as the minimum of these R's. So this is the L that I'll pick, and this is the R that I'll pick. If there is any intersection in these, like L is less than equals to R, then it's possible for my friends, for all the friends, to meet at a point, right? So it's possible at this time for all my friends to meet at a point. So I'll keep binary searching on my time. Is it clear? Yes, no?
Yes.
So can I show you the
So meet represents a position.
No.
And
Yes, meeting, like, yes. If L is less than R, there is at least one point at which my friends can meet after this time, after this mid time. But actually I don't have to print the meeting point, I have to print this time only. So I have to minimize this. Here in ternary search, this was the point on which I was meeting and this was the time. So I had to print this value. This is the time, minimum time. Here we were ternary searching on the distances. Like we were operating on distances. In binary search, we are operating on time itself. Is it clear?
Can you please explain the time part once again?
Like this thing is not clear. Earlier, like ternary search was clear. This is not clear, right?
Yes.
Okay. So let's say this is your time, like this is your complete distance or the coordinate line. Your one friend is here. You know what is the coordinate of this? Let's say this is x and the speed v. And currently, like you have time as mid. So the lowest, like the minimum place at which this point, like this friend can go is nothing but x minus v into mid. That is time, right? And the maximum that this friend can reach is x plus v into mid. So for each friend, you can find what is the lowest place that they can reach and what is the maximum place that they can reach. So finally, for each of these, let's say this is your time, this is your distance coordinate line, and one friend can go from here to here, another friend can go from here to here, and one friend can go from here to here. So just pick for all of the friends, which friend can go, like what is the maximum place that a friend can go, like what is this left maximum, because there is one friend that cannot go beyond this. So let's pick this as our L and also pick this as your R. Why? Because this after this point, there is a friend which cannot go. So if L is less than or equals to R, this means that there is at least one point on which your friends can meet at mid time. Is it clear?
So it could be either L or either R.
It can, like the point doesn't have any significance. If L is less than R, since it's given that the point of meet doesn't have to be an integer. It can be something like in this between. If L is this, maybe L is 0.5, R is 0.75, then also it would work. L should be just less than equals to R. The point does not have to be an integer, the meeting point. Is it clear?
Why can't we operate on distances using binary search? Like if I fix a point of meeting, then I can find out the time for each friend not to go to that point, and I will pick the maximum time.
Okay, how will you, like distances is okay. Okay, you are picking like this is the point that you'll meet. It's showing that
Yes.
okay, you can meet. So what will you do after this? That you can meet at this point then?
So now I will calculate the time for each friend to.
How will you minimize time? How will you minimize time now?
Yes.
Where
No,
will you
I will take the time. I will take the time and I will pick the maximum time now here. So this will be the time. Now I will check for another. Okay.
Where
Yeah.
will you shift? Will you shift left or will you shift right?
Yes, yes.
So that's why
Okay.
you can operate on time directly on binary search. Like you cannot operate on distances. You cannot operate on distances in binary search. Is it clear?
Yes.
Like even if you like, you said, okay, this is my distance, like I'll meet here, and you calculated for each of the friends how much time they are taking to reach this point. But how will you minimize? Whether you'll shift left or you'll shift right, how will you know? So that's why. So now I'll show you the implementation. Just give me a second. Where is it? So another search solution is simple only. I'll show you the binary search solution because it's working with errors or everything. Okay. So this is the solution. In this, I'm taking n as input. Then I'm taking those. This is the point and this is the speed. The first value is the point itself and the second value are the speeds. So for each and every friend, I'm taking both of these as input. Then I'm sorting the values according to their coordinates. Like this friend is here, this friend is here. I don't think that this is actually required. But just for the convenience, I'm sorting them according to their points, like according to their lying in the coordinate line. So initially my low is 0 and high is this, and answer is anything like which cannot be, like initially after this point, each and every friend can probably meet. So that's why I'm taking answer as this. Now this is the error that I want. I want it to be less than 10 to the power minus 7. So while my high is more than low, high minus low is more than equals to this error. What I'll do, I'll pick the mid. Mid is actually this can be high plus low plus high by 2, right? So this is high plus low by 2. Then this is the leftmost point that I can go, like that my any friend can reach, and this is the maximum point that my any friend can reach. Like so, like I said, I'll from all the L places, from like all the L points, I'll pick the maximum one. And how to pick the L for each friend? This is the point at which my ith friend is, and this is the point that it can reach, right? So this is x minus v times speed, like v times time, v times v into mid. So I'm picking from all the L possible values the maximum one, and from all the R possible values the minimum one. So finally, if my L is less than equals to R, my answer will be minimum of answer time or mid. So instead of doing this, I can do answer is equals to mid. And my high will be, like I explained in last class, it will be mid minus EPS. I'm shifting to the left range. Otherwise, I'll shift to the right range. Finally, I can print answer. You need to make sure that you're printing your answer in the, like, using precision. If you're not using precision, otherwise your answer will get rounded and you'll get, like, even you have calculated the correct answer, you'll get error. You'll get wrong answer. Is it clear?
Yes.
Hello.
Yes.
So there is no error concept in ternary search. Is there?
There is also error, but that error actually is not on time, but it is on distance, and that is easier to implement. Like ternary, this thing is easier to implement, right? You just have to check value here and here. If you want, I can share the code for this also. I'll share this code after the class. Okay, like it is easier than binary search solution. Is it clear? Like this problem can be solved using binary search and ternary search both. Ternary search will be applied on the distance, and binary search will be applied on time. So
Can
I
we
hope
discuss
this
it here?
I have already discussed this ternary search.
Is the code part.
Like you just have to find mid one and mid two, and if mid one and mid two, if the value at mid one, like the time it takes to reach mid one is more than mid two, what you will do, you'll shift your left boundary to mid one. Otherwise,
Here we
change
are
it.
taking the distance.
Like
You are working.
you at this distance, you get the time, right? Function.
Yeah.
Yes. How will you get it? If you know you have to reach here, find for each friend how much time it is taking to reach this point, and from all of these values, pick the maximum time. So that is this value. So at mid one distance and mid two distance, these x values, find this function value. If it turned out that the function, this value turned out to be more than the function value at this point, change your lower boundary to mid one. Otherwise, change it to mid two. That way you get this point of minima, and then this point is your answer. Like this is your meeting point and this is your answer. Is it clear?
Yeah.
So is it clear to everyone?
Yes.
Okay, so we have covered all the problems. I hope like now you'll be more confident in these. So that's it for today. I'll upload all the session, like the slides and the code also. In maybe I'll give it to the managers and they'll upload it by tonight, so you can view the like the slides, all the discussion that I have like written. So that will also be available. So thanks for joining and bye bye. And combinatorics